Hello everyone, I'm Priyanka Golia and I'm going to talk about our work on designing tester and sampler in Tandem. This is a joint work with Mathesus, Saurabh Chakraborty and Kuldeep Meel. So let us first introduce the notion of uniform sampling. Given a formula F, the problem of uniform sampling seeks to sample solutions of F uniformly at random. Uniform sampling is a fundamental problem with a wide variety of applications that includes constraint random simulations, constraint-based fuzzing, configuration testing, and bug synthesis. The computational intractability of uniform sampling has led to the development of sampling techniques that uses heuristics and does not provide any theoretical guarantees. The lack of guarantees of various sampler is often compensated by demonstrating generated distribution over a small sample of benchmarks. Therefore, we need a tester to test whether the sampler is indeed sampling uniformly at random or not. Towards this, Chakraborty and Meel proposed the first scalable sampling tester called Barbarik. Barbarik rejects a sampler if the distribution generated by the sampler is far from uniform, and it accepts a sampler if the distribution generated by the sampler is close to uniform. The availability of Barbarik has potential to spur various development of sampling methods that can be accepted by it. Towards this, we designed a new uniform sampler called CMSGen. CMSGen modifies the existing state-of-the-art CDCL-based set solver crypto-miniset to attempt to produce uniform samples. Since the understanding of the behavior of CDCL itself is a big open problem, CMSGen cannot provide unconditional analysis on the distribution generated. However, upon testing with Barbarik, it turns out that Barbarik accepts CMSGen for all the benchmarks. The table here lists two other samplers, Unigen 3, which is a state-of-the-art uniform sampler that provides theoretical analysis, and the quick sampler, which does not provide any theoretical guarantees. Note that Barbarik rejects quick sampler for all the benchmarks. Next, we show that CMSGen provides uniform samples without significant loss of runtime. On comparison with Unigen 3 to sample thousands uniform solutions, it turns out that CMSGen outperformed Unigen 3 with a geometric mean speedup of 420 times. Furthermore, we analyze the impact of CMSGen on the applications like combinatorial testing. In the combinatorial testing, the main challenge is to generate the test configurations that seeks to maximize t-wise coverage. The plot here represents 2-wise coverage for 110 benchmarks. It shows that with quick sampler, average coverage is 52%, whereas on the other hand, for almost all the benchmarks had nearly 100% coverage with CMSGen.